Today, we are going to do an overview of the builder patterns. We will start with the non-consuming builder patterns, with a reference of self, and we will compare it with the consuming builder patterns with just self. And first, we are going to get an overview of the constructor patterns from the struct literals to the constructor functions, to the default, and the mixing of struct literals with constructor functions. Okay, so first let's start with a simple struct task. We're going to make it debug because we're going to print it, and we're going to have public properties, title, the done flag, and the description, which will be an option of string. So the simplest way to build that will be to do a struct literal, which will be a let task, the type task, and then for each properties, we're going to set the value. And then we can do a print task and the nice debug. We are bringing our terminal, we do a cargo run -quiet, and then we can see that we have our task with our 3 properties. So that is the simplest way, and in many ways, for very simple data, this is perfect. The next step is to create a constructor function. So for that, we're going to implement task, and we're going to have an associated function without self, obviously, because it's going to create the task instance. And for this new function, we're just going to take the title. And we're going to follow a pattern here, which is the import into string, which will allow us to pass reference of a string slice, or a string on value. And it will only do the allocation if needed. And then it will return task. And now we're doing our task literal inside the constructor function. We're going to set our title with the .into, which will create a new allocation only if a reference of a string or a string slice is passed. And then we're going to have the done false and the description none. Now, if you have multiple constructor functions with different properties, one pattern that is used sometimes is to have the with underscore and then the properties that you are using. But in our case, new will be enough. Then the way you will use that will be with task, : and then our new, and we're going to give our task 01. We get our terminal, cargo run -quiet, and now we get our value back. Oftentimes, it's useful also to have a default implementation of task. And so in this case, we are going to manually implement the default trait. I have a little code snippet here that allows me to implement that. And we are going to implement default for task. And in this case, we are going to return self, and the title will be just untitled. We could also derive the task with default. We are going to see that later. But this way, we have the exact control of each field. And now the way you will use that will be rather to do a task new, you will be able to do a task default. Then you do a cargo run, and then you get the default fields. The benefit of implementing default is many other functions that can use the default implementation of your type. So for example, if we have a task, which is an option of task, and we're going to set it to none. And so now for this new definition, we're going to do a task dot unwrap or default. And so the option function unwrap or default will either unwrap what is inside the option, and if there is none, it will return the default. So that means that our second task variable is of type task. And now if we do our cargo run, then we get exactly the same data. So implementing the default is often very useful. Now another use of the default is when you are building with the struct literal. So for example, here we want the done true. We can do a syntax, which is a ... which means remaining of the properties that hasn't been defined, and we can take it from the default. And now if we do our cargo run, we see that we have the untitled and the done true. Now the cool things about the remaining pattern here is that it doesn't need to be default. So for example, here we can call our constructors that we built before, which is the task new, and then cool task. We do our cargo run, and voila. We get our title, which is from our constructor, and we get our done true, which is from the struct literal. So the constructor patterns and the struct literals are very good patterns, but sometimes you have more complex objects that you want to build in steps. So we're going to take the example of a web request builder, where we want to build a request in steps. So first we're going to create our module web. We're going to use our create prelude. That is a pattern that I like to follow for our error and result. Link in the description on how I start my new projects. Then we are going to define our request struct, which is going to be the object we want to create. And for now, all of the properties will be public. We will see later that actually this is not needed. So first we have the URL, which will be a string. Then the methods, which will be a string in our example. Eventually that should be an enum. And then we're going to have our headers that are a vector of a tuple for our name values. And then finally, we're going to have our body, which is going to be an option of string. Then obviously, this is a very simple example. A full web request will be a little bit more complex than that. And then we're going to derive it with a debug because we're going to print it. And now we're going to create our request builder. So basically, it will be the same structure. So we're going to copy paste it. We're going to call it request builder. And now all of the fields will be optional. So URL will be option of string. Method will be option of string. The vector for now, in this simple example, we're going to keep it as a vect because if it's empty, that will mean that there's nothing. But eventually you might want to wrap this as an option of vector as well. And then the body is already an option, so there is no need to double option it. For now, these members are going to be public, but we're going to see later that actually we don't want them public and it doesn't need to be public at all for this pattern to work. And now this one, we don't need a debug derive, but we're going to have the default derive. So in this case, rather to implement the default ourselves manually, we're okay with default implementation, which all the options will be none and the vector will be empty by default. So now we can close the code like that, and we're going to implement the request builder. And the first one will be actually a constructor function, which will return self, which is the request builder. And for that, since we have derived request builder with default, we can just do request builder : default. So that is another good use of the default implementation. And now for each property of the request builder, we're going to implement a pub function that will take a reference of mute self. So that is a non-consuming pattern, which means that every time it will take just the mutable reference of self, such as it will change it in place. And now we're going to take the URL and we're going to follow the same pattern here of impair into string. But here again, if you prefer, you can just pass string or reference of string. And now the important part is obviously you want to return reference of mute self. So basically the same self you get in the argument, you want to return it, such as we can chain all of these functions. And now we're going to do a self URL and we're going to assign the sum of the URL.into. And again, the .into will just do a new allocation if a reference is passed, but if a string is passed, that will return self. There will be no new allocation. And then we're going to return self. There's still a little optimization we can do on this function. We'll see that at the end. And now we're going to take this function, paste it here, and do the same thing for methods. We're going to do the same thing for body now. Let's close some code here. And now we can define the headers, which is a little bit different. And the design currently of this builder will be to take the header one by one. You can also have the headers both ways, but right now it's just going to be one by one. So we're going to take the reference of mute self, the name, which will be the implementation of into string, and then the value, the same. It will return the reference of mute self as the others. And now we're just going to push this new name value into our vector of tuples. And that's it. We return self and we're good to go. So that will be our chainable functions. And then the last one will be our build. So it will be public function, build, and that will take a reference of self. And that is very important. We're going to see why later. And then it will return a result of the request. Because in our case, it could fail. So if there is no URL, for example, it will fail. So that's why we included the prelude at first, but you can have your own standard error here. We're going to put our to-do to make sure we don't have too many compile errors while we're writing the code. And now the first step will be to do a guard on making sure that we have a URL. Otherwise, we're going to return an error. And for that, we're going to use a new let-else pattern. So we're going to let some URL equal self URL. And the trick here is to make sure that we do the asref, because we don't want to move out the value of URL because we just have the reference of self. We're going to see later other strategies. And then we're going to do the let else pattern. And if we don't have a value inside this self URL option, we're going to return our error. And that we're going to use the error that we have in the prelude, which is just a static. And we're going to say no URL. The error static is just a temporary one while I'm building the code. And then eventually I get rid of it and I make sure that everything is fully typed error. So that allows me to have the error flow correct and I fix the error type later. But obviously you can have your own strategy. So for method, we want to default to get. And the way we do that, we're going to do first, same strategy as before, we're going to clone it. So this way that will allow us to have the string. And then we're going to do an unwrap or else, and we're going to return our get to string. And now that we have that, we can just do an OK. And we're going to do our request, our URL, and we're going to do a URL to string because we had the asref up there, which means that URL is a reference of string, and we need to have our own string for the request object. And then we have our method, which is already a string, and our headers, which is very simple in this case because we're just going to clone, and our bodies that we're also going to just clone. So remember, in this case, because we do not mute self, we cannot move data out of self, so we have to clone the data because our request object needs to own them in this example. Now, if we get to our main, we're going to use our request builder and our request object. We wouldn't need really the second one, but anyway. And now the way that we will create our request will be with a request builder new, and we can chain each property like that. So we're going to have the URL, the method get, and then we're going to add one header. And then at the end, we're going to do the build. And now if we do a print, rec, nice debug, we bring our terminal, cargo run -quiet, and we get our request. Obviously, we can add a little question mark over there. And if we run it again, we just get our request here. So far, so good. Now, often what we want to do when we have a builder pattern is we want to split things up. So for example, we want to build our request at the beginning. So we're going to do request builder. And then at the end, we're just going to have our request equal the request builder, header and build. And then at the middle, we'll do some stuff. Now, if we press save, we actually have an error over there. And the reason why is because the request builder new returned the request builder, but then the method returned a mutable reference of request builder. So there is nobody to own the request builder itself. So if we mouse over, we can see that temporary value drop while borrowed. So the way to solve this is to end the first request builder new, make it mutable, and now we can have the request builder and we can change them like that. And everything will work because the request builder variable is going to hold request builder. And then at the end, we can just build it and it will return our new request object. Let's fix a little bit the layout, such as we can see better. And now, since we are cloning everything, we can see that we can call the request builder multiple times. So for example, we did the first build, but now we're going to use the same request builder. We are going to add another header. And then we're going to build a new request with the same request builder. We're going to print it. And if we do a cargo run, then we get our two requests. The first one, and then the second one with our new header. So that is pretty neat, because you can keep a request builder and reuse it in multiple places. So now we have a little issue here, is that even if we use the builder once, it will always clone the data. And that is because we have the reference of self, so we have to clone everything because we cannot mute it, we cannot take the value out. So one way to solve this problem, and that is a danger zone, I wouldn't recommend that, is to have the build taking a reference of mute self. And now our logic can take the values from the options, and we don't need to clone anymore. So the URL is just the URL, method the same way. For this example, we're going to still clone the headers because otherwise it would be more code, but the point is the same. And now for the body, we're also going to just take it. And now if we get back our main, everything compiles nicely, so nothing changed. And if we do our cargo run, then we get the first request, but then for the second one, we get no URL. And that is because our first build moved out the URL to the request object. And so our second build doesn't have a URL anymore and fails. that could be considered kind of a bad API because calling twice the same function has different results. So let's clean this up. So we're going to go back to where we were before. And so now we have our reference of self, doesn't change anything, and we can call our builder many times. And if we do our cargo run, we get our 2 requests back. So far, so good. So now let's see the consuming builder pattern. So rather to take reference of self, we're going to take self. And now, because we're consuming the data, we can move it, because anyway, nobody will get the builder after, since we are returning result of request. We don't need the asref clone anymore, because we can move the data. That just becomes a URL, and we don't need to clone the headers or the body. Now, to make that work with the rest of the functions, we need them to take self, and in this case mute self, because they are going to change themselves, and return self as well, because otherwise you wouldn't be able to chain to build. And so we do that for all of the function. We're going to remove the reference of mute and make it mute, and then we're going to return just self. Now if we fold our code, we can see that all our builder methods return self and take mute self, and our build consumes the self and return the result of request, so the request builder will be dropped. So now if we get our main, we see that we have some compiler error. So the first one we can fix is we don't need to split the request builder new anymore because everything is on. So we can remove the mute there, and then we can go from new to URL to methods, and that will work fine. And for now, we're going to comment the second build, and we will see later how we can have it back. So now if we do our cargo run quiet, we have our request object. Now, one key difference with a non-consuming builder pattern is that every time you split your building logic, so for example here if we want to do other stuff in between, we need to always keep a handle on the request builder, because every method will return self. So we want to make sure that we can keep the request builder. And then at the end, we just do our request equal request builder dot build. So now if we wanted to uncomment the second build, we can chain all of them. So we're going to do a let request, request builder, and the build, for example. That will be enough for now. If we press save, we're going to get an error over there, because the request builder was moved in the build that we just called above. So we don't have it anymore. So the way to solve that is actually pretty simple. Go back to your request builder, and we're going to derive from clone. So that will allow us to clone the request builder. And now if we get back to our main, when we call it first, we're going to clone it first. And now we press save and everything works nicely. If we do our cargo run, we get our first request and our second request. And so the data was cloned only at the first building and not at the second one. So in a way, with a non-consuming pattern, we had one extra clone, because even the first build was cloning the data to keep it for the next one. So with a consuming request builder, you have to be explicit with the clone, but then you do not have to clone for every build, because the last build will just do a move. So that's why in general, I prefer consuming builder patterns. However, for the non-consuming one, when you don't need to move the data to the objects that you are building, then the non-consuming pattern might be a good option. Now, there's few things that we need to clean. First, if we go back to the request builder, typically the properties of the builders shouldn't be public. So what we're going to do is make them private. And that is usually what you want, because the methods below are the one publics, and this one shouldn't be exposed to the outside world. Now, if you go back up, you can see that our request object also had public properties. And that really depends on how you want to expose your objects to the user. But the nice thing with this builder pattern is that they don't need to be public. So for example, in this case, we can make them private and everything will work exactly the same. Now we're going to do one very final touch, and that is in our function, in the URL, for example. Here we're doing a new assignment with a new option. But in fact, what we could do is just doing an insert with a URL into. And that rather to create a new option, it will reuse the option that we already have, and we'll just put the new value in it. So the old one will get dropped if there were one. And so we can do that for all of the methods, and the body. And if we do our cargo run, everything works exactly the same. That was just some cleanups. And that's it. That is basically the builder patterns that you can use when you are building relatively complex objects. Hopefully you found this episode helpful. Until next one, happy coding.